Good morning. Our topic for today is continental drift. Your objective is that you can evaluate evidence that supports Waggoner's theory of continental drift. This is the Earth as we know it today. There are the 7 continents, just as you would find today if you were to travel around the world in an airplane. Over 100 years ago, however, there were 2 groups of scientists that had opposing or different ideas about how the Earth's surface got to be the way it was during their lifetime. So how did the Earth actually become to look the way it did in this picture? The first group of scientists were known as the fixists. They proposed something called the conventional theory. This stated that the continents were stationary, meaning they never moved, but instead were once connected by land bridges that over time broke apart and fell into the ocean. There then was a second group of scientists that supported a man named Waggoner. Alfred Waggoner proposed a very different theory. He believed that all continents were once joined together in one giant single landmass known as Pangaea, that then over time actually moved and drifted apart. You're going to watch a video about how Waggoner made this proposed theory about the continents moving apart from each other. As you're watching the video, underneath your note that you just wrote, on the left-hand side, I want you to write evidence, and on the right-hand side, I want you to write down 2 pieces of evidence, 2 examples from the video that supported Waggoner's theory. So what were 2 things that he discovered that made him believe that the continents were all once one giant piece of land?
Germany, 1911. A meteorologist named Alfred Wegener was browsing through some books when something caught his eye. A list of identical plant and animal fossils that had been found on opposite sides of the Atlantic Ocean. Wegener was intrigued. How could the same species have gotten from one part of the world to another? He examined the eastern coast of South America and the western coast of Africa, and was struck how the shapes of the 2 coastlines might fit together. The more he looked, the more links he found. Species of land mammals in East Africa also inhabited the island of Madagascar. How did that happen? Did the animals evolve in both places at once? Or did they somehow cross from one land to the other, swimming hundreds of miles across the Indian Ocean? And then Wegener saw it all clearly. He realized that all the continents in the world had once formed a giant single landmass that he called Pangaea, from the Greek Pangaea, meaning all earth. It was in Pangaea that the plants and animals found on opposite sides of the world had once shared the same home. Then, over hundreds of millions of years, Pangaea had split apart, and its jigsaw pieces had drifted to their present locations. Wegener called his theory Continental Drift. Wegener wasn't the first scientist to speculate that the Earth had once been dominated by a supercontinent, but he was the first to pull together all the evidence and make a strong case for it. Unfortunately, his peers weren't very receptive. There was no mechanism to explain how the continents might plow through the oceans. Continental drift was just too incredible to believe. As a result, his discovery was largely ignored.
So his discovery was ignored because he was missing something. But let's first review what the two pieces of evidence were that he had that would help people understand his theory. His first observation, his first piece of evidence, was he noticed that the shape of the Earth's continents fit together like puzzle pieces. So next to your notes that you used for the video, make sure that you have what the two pieces of evidence that are in green written down. So the shape of the continents looked like they fit together like puzzle pieces. That was his first piece of evidence. And second, he noticed that there were fossils or remains of the same animals and plants that were found on the coastlines of different continents. So he found the same animals fossil in Africa as he did in South America, which further led to support his idea that they used to fit together like a puzzle. In addition to these two, he also discovered that mountain formations were similar on different continents. There were similar rock layers and also similar groove marks from glaciers, which are giant slabs of ice. So sadly, these two pieces of evidence, the fact that they fit together like puzzle pieces, and the fossils that he found of different organisms, a lot of the scientists of his time back in the early 1900s rejected his theory. He was not able to tell them how exactly the continents broke apart. And this mechanism, will be discovered 50 years later, which we'll talk about tomorrow.